Hi again, everyone. Thanks for joining and welcome to Lineal Cyber's penetration test webinar, Know Your Vulnerabilities. So we're running this webinar to give you an overview of what we can offer you with our penetration test service, as well as demoing a live attack. There are some housekeeping points you should know before we start. The webinar is going to be recorded and will be available shortly after the webinar has finished, and all microphones will be on mute for the duration of the webinar. However, there is the opportunity for a Q&A at the end via the chat facility. We will aim to answer all questions. However, if the time gets the better of us, our team will contact you after to answer these for you. So the way we're going to run this is pretty straightforward. We're going to introduce who Lineal Cyber are and give you an overview on what penetration testing is, what we're regularly seeing when targeting a network. Following that, we'll discuss the different types of penetration test services there are, how these can benefit you, and other areas we can assist in. Finally, we'll be performing a live demo on the client-side attack, which will follow into any questions. So I'm Stacey Payne, and I'm the cybersecurity consultant here at Lineal. And my role is to assist customers like yourself with vulnerability identification. I'm joined by David Martin Woodgate, who's our Director of Forensics and Incident Response. David has over 20 years of experience in Her Majesty's Armed Forces, working with communication technology and counter-cyber terrorism. Following that, he also has 7 years in the private sector, where he focused on modernising cybersecurity systems and organising cyber response teams. Lineal Cyber provide bespoke solutions to your problems, giving you full confidence in the process and the delivered outcome. We operate at the cutting edge of cybersecurity technology, using our expertise to exceed your expectations and operate within budget and timeframes. We will partner with you to help protect your organization against one of the biggest threats of modern age. Our cyber consultants work to develop ongoing risk assessments and then implement the policies and procedures required to put all necessary countermeasures in place to limit and contain cybersecurity exposure. By working on a cyber resilience model, we help you to identify weaknesses in your systems, creating a plan to minimize business disruption in the event of an incident and keep you one step ahead of potential cyber threats. So without further ado, I'm now going to pass over to David to move forward with the webinar.
Thanks very much for that, Stacey. So what we're going to look at now is what is a penetration test and what do we see? It has been said that if you have an internet presence, then you're already getting a penetration test just without the report. And I'm sure that each of your organizations have experienced an incident with or without your knowledge in the past. If you have a look at the web access logs for your website or the external login portals, as an example, you'll no doubt have identified multiple attempts to bypass this security using either injection techniques or scans being performed by non-authorized attackers, just to find out if you have any vulnerabilities present of which they can exploit later. So, a penetration test, colloquially known as a pen test, is an authorized simulated cyber attack on a computer system performed to evaluate the security of your networks. We can look at breaking this sentence down into three separate parts. The authorized attack, the computer systems identified as being within the scope of testing, and lastly, the evaluation which comes inside the reporting and remediation and retesting activities. Each of these elements needs to be well defined, understood, and agreed by all parties prior to any testing being performed, as any deviation to testing may well fall inside the Computer Misuse Act and may also impact upon critical business systems, providing the organization with a potential loss of BAU. There may be reasons why an organization will need to undertake a penetration test, some of which could be required to maintain compliance within a framework, such as Cyber Essentials and payment card industry, as a sample. Best practice against auditing standards, such as the CIS 20 controls, or just to gain a view of the organizational stance in order to be able to map the organizational risk against any vulnerabilities identified. Therefore, the benefits of performing a penetration test will be different for each organization undergoing the audit, but mainly fall within the following: being able to identify and order vulnerabilities, to meet compliance requirements, protection of customer data, eliminate service downtime, and to minimize costs incurred as the result of a breach. Penetration testing can be performed as often as an organization would warrant it. However, there are some suggested trigger points that an organization may have to adhere to having this test performed, in line with these initial recommendations. So when there's been a change in the network, be that internal or external infrastructure and services, in line with compliance requirements that an organization is tied against, when there has been a new threat identified against the organizational, operational, and business systems, or lastly, upon joining of organizational networks post-IT configuration. Once the testing has been performed and the report has been drafted, the organization can then update the risk register with any additional vulnerabilities identified, thereby allowing the C-suite to understand the organizational risk more clearly. And furthermore, they can assign resources as necessary to perform any additional mitigation steps as required. The approach to testing should also be considered, as the organization may require a specific testing script to be performed in order to maintain compliance against the defined standard, such as CREST and PCI DSS, just to name some. Therefore, this test will be performed using a defined testing schedule, which will allow the external compliance auditors to have evidence and confidence that the correct internal control measures are being undertaken. Additionally, there are frameworks within which specific testing activities can also be measured against. A few of these methodologies are the Open Web Application Security Project, OWASP Testing Guide, the Payment Card Industry, PCI, Penetration Testing Guide, the Penetration Testing Execution Standard, or PTES, Open Source Security Testing Methodology Manual, OSS-TMM, and the Council of Registered Ethical Security Testers, CREST, Penetration Testing Guide. There are many more methodologies, but these can be discussed at a later point if there is a requirement. So now we're going to look at the types of testing. First of all, we have external penetration testing. This type of testing assesses an organization's infrastructure from an external perspective, sited outside of a perimeter firewall upon the internet. It is designed to assess the organizational infrastructure from the perspective of an external threat actor. The external pen test will seek to assess the security controls configured on the access routers, firewalls, intrusion detection systems, and web application firewalls that protect the perimeter of the organization. External tests will also provide the ability to assess security controls for web-based applications that are published through the internet as an external service to corporate users and clients. It is understood that there is increasing logic being built into web services to deliver functionality for internet users, so these need to be tested also. Now we look at the internal penetration testing. This type of testing assesses security through the eye of an internal employee, a temporary worker, or a third party that has physical and/or logical access to the organization's internal networks and infrastructure. Internal penetration tests are conducted from within an organization, over its local area network, or through the organization's wireless networks. Testers will initially assess the environment without credentials and determine whether a user with physical access to the environment could extract credentials and then escalate privileges to that of an administrator or super user within the environment. During an internal penetration test, the tester will attempt to gain access to sensitive data, including PII, payment card, research and development material, and financial information. The team will also assess whether it is possible to extract data from a corporate environment and bypass any countermeasures or controls that are in place. Web application testing is becoming increasingly more popular, but this also means that they are particularly vulnerable to attack also. A web application handles sensitive data, so it is important that the organization can ensure that these web applications are not presented as a risk to the business. The web application test is conducted within several stages, including enumeration, vulnerability discovery, and exploitation, all of which are important in identifying whether there are any risks to your networks. Due to the complexity of the infrastructure being assessed within these web application tests, the tests that are placed against the application can be lengthy in time. A few of the tests identified are as follows: path traversal, remote file uploads, cross-site scripting, SQL injection, server-side code injection, remote operating system command injection, buffer overflows, parameter tampering, and input field validation testing. The framework for testing web applications is detailed within the OWASP testing methodology, of which we referenced earlier within this presentation. And lastly, we look at social engineering. Rather than looking just at the technology in place, social engineering identifies the need for testing of human error. Clicking on links or documents within phishing emails, or even visiting insecure websites, all providing a backdoor into the corporate environment for an attacker to exploit. Social engineering tests are designed to help assist organizations increase their security posture and reduce the risk of insider threat attacks. For the remainder of this session, we'll be focusing on the client-side attack, of which I will first provide a few examples of how companies can be attacked and what to look out for in addition to the live attack within the contained environment, which we'll see at the last part. So inside this slide, we see the client-side attack. In the majority of cases, a client-side attack is performed by an attacker being able to compromise a terminal to be able to gain access to corporate information, be that login details, PII, or corporate sensitive information. In this case, what we see is that the attacker is intending to harness an internal user to divert the traffic to an external source, the web server. This server may be holding a login page similar to a network resource, which will ask for the company credentials of the user as an example. The way that this scenario is set is that the attacker is sending a malicious email to an internal user, in this case with a link to the malicious web server. The internal user then clicks on the link and is redirected to this malicious web server where credentials are caught, thereby providing some valuable information to the attacker. The attacker can now use this information to potentially bypass network security controls in place at the firewall and network resources. The second example I'll explain is the sending of malicious payloads. These are most commonly contained within documents, such as common office documents or PDF documents. And they're designed to fool the user into opening the attachments to the emails and thereby spawning the malicious payload. Once opened, the victim's device will execute the payload contained within the document, of which in this case is opening a remote connection to the attacker's terminal. This then provides the attacker with the ability to further compromise the terminal with additional attacks once connected. So within the live attack, what we'll perform now, we will be using two virtual machines to display, that being a Kali Linux terminal, which will be the attacker's terminal, and this is an open source capability freely available to anybody on the internet. And secondly, the victim's vulnerable host will remain a Windows 7 terminal. All of the tasks undertaken within this lab have been undertaken with open source software from the perspective of an attacker using the Kali Linux 2019 build, which is available to download from kali.org. So the assumption is that the attacker has been able to gain access to a corporate network, either by wireless attack or network attack, and has further been able to access the corporate LAN. So here we have our Kali terminal, and I'm just going to log in. And secondly, we have our Windows terminal. As you see here, the Windows 7, and it's connected to the network with the IP address 10.16.122.104. So if we just switch back to our Kali desktop, here we see we are also connected to the internet using 10.16.122.155 as our IP address. So as we said before, the assumptions are that we've gained access to the network, and we're on the corporate local area network now. So what a user will do when they attack the network is they will have to identify what's there. So one of the tools that we'll use within this phase is a tool called ZenMap. ZenMap is a network scanner, and it is a graphical display of the application Nmap. And as you see here, I've performed a scan previously on the subnet of the 10.16.122.0 range. And as you see here, we've identified the following terminals as being live on the network, and any additional information such as the output, the ports and hosts open, the topology of the network, and any host details as necessary. So here we have a lot of information. And we've identified one terminal, as we saw with our Windows terminal, the IP address 10.16.122.104. So we can now look at this terminal in a bit more depth and identify what's running underneath. So if we now look at the ports and hosts, we can see that the various ports open. We can see that it's a Windows terminal, and we can understand the services that are running on this terminal also. So of note here, we can see that the SMB service is being provided. We can have a look at NetBIOS and the remote procedure call. Each of these services being run here could be potentially vulnerable to attack, and this is what we're going to look at now. So we've identified our target terminal as 10.16.122.104. What we'll do now is take a deeper look into this. So what we would use is a vulnerability assessment scanner. And what this scanner will do is highlight any particular threats and highlight them to us, given their severity, the host itself, and the location, and the vulnerability itself. And here we see, we spoke previously about the Windows SMB service. So we can have a look at this and understand how the terminal could be exploited. So here, as you see, if we drill down, we can identify that the Microsoft Windows SMB server has multiple vulnerabilities against it, and it's of high severity. Additional information at the bottom within the references provides us with some additional information from the CVE, the certs, or any other supporting documentation sets. Okay, so we've identified that this terminal is now vulnerable to attack from the Kali terminal. So we can close this service down. And what we would do now is look at exploiting the vulnerabilities that are present on that terminal. And for this session, what we would do is use an application called Armitage. Armitage harnesses the functionality of Metasploit, but provides it in a graphical interface just for ease of use during this webinar. So we've opened up the terminal here. Now what we need to do is insert the host. So we can add a host quite easily. By input it into the screen. And we now get the display to say that the host has been added. Okay, so we don't know a lot about this host yet, or the application doesn't. So what we can do from here is we can run a specific set of scans against it. So here I will look at just creating a quick scan with an operating system detect against it. So as you see here in the console pane, the script is running and the test will be performed against the terminal itself. Very much like what we would see as an output against the Nmap or Zenmap application. And as you see here, the information that's been provided is very similar to the Nmap because it is, as you see here, the Nmap module that's running within Armitage itself. And also we see here that the terminal has been identified as a Windows terminal. And if we look through the information of this, we can then understand that the ports are very similar to what we saw previously, with 135, 139, and 445 being open. Okay, so to understand this a bit better, we can now start looking at attacking this terminal. But what we would do is go directly into the attack. However, we would look at providing this attack in a very short, slow fashion in order that we don't get identified on the network. However, for today's session, we can go directly into the attack. So we know that this type of terminal, the Windows 7 terminal, is vulnerable to the Eternal Blue, or could potentially be vulnerable to the Eternal Blue attack. So what we can do, first of all, is place an attack against it. And this scan that we're placing onto the terminal now will let us know whether or not this terminal, the attacker, the victim host, is vulnerable to the SMB attack. And as we see here at the bottom of the screen in the console, the host is likely vulnerable to this type of attack. So we can take this one stage further now. We can choose the attack itself and place it onto the host. We'll change to use a reverse connection. We don't need to change any of the information within the boxes, and we can launch the attack. And as I've said previously, all of these attacks can be performed within Metasploit. However, for ease of use today, we're using Armitage to harness this functionality. So as you see here, there's a lot of traffic that's being sent to and from the device. It's sending server message blocks, it's sending buffers, and it's overwriting specific toolkits. Okay, now you see that the terminal itself, 10.16.122.104, has been successfully exploited. And the way that we can identify this is that the terminal will go red. So now that the attacker has been able to progress this far, the attacker now needs to look at performing some additional tasks against this device, such as interacting with the terminal, spawning an interpreter session, posting modules to a terminal, or disconnecting the sessions that are created. And as you see here, through this, we can interact with the terminal. We can look at spawning the interpreter shell. We can post modules or disconnect. Okay, so there's not a lot that we can do at the moment. So what we need to do now is start looking at spawning a Meterpreter shell. And once this Meterpreter shell is open, the attacker will be provided with a lot more functionality to perform additional exploits against the compromised Windows hosts. What we'll start to do now is look at spawning this shell that we've currently got open to a Meterpreter session. And as you see here, we're starting with reverse handler again on another session. And once confirmed, we will see that we have the Meterpreter functionality come up into this script. And here we see that Meterpreter session 2 has now been created. So we have a lot more functionality here, as I said previously. We can access the device itself, so we can escalate privileges, steal tokens, dump hashes, and persist. We can interact by placing a command shell of the target device. We can create a Meterpreter shell, or we can look at creating a VNC to the desktop of the terminal itself. We can explore the terminal, looking at browsing files, showing processes, logging the keystrokes, taking screenshots, or even taking a webcam shot of the terminal. Or we can utilize this terminal as a pivot. And the reason we'd use this terminal as a pivot would be to then identify additional resources within the network that this terminal has access to. But for ease of use, today what we'll look at taking is escalating privileges. So here on the left-hand side, you see there are lots of exploits that we can use against this system. So what we can look at, if it's a server, we can get the golden ticket. However, as this is a terminal, we just get system and place the get system on the terminal itself. And the system will work for us. Okay, so this is looking at getting the system credentials, getting the access to that high level in the PC itself. Okay, so as you see here at the bottom, the system already has system privileges. So what this provides us with is the ability now to perform additional tasks at the system or administrator level on that device. And to look at this, we can interact by creating the command shell. And here you see we have a Windows command shell that's been opened up. So this is from the device itself, the compromised host. And here I can place who am I? And here we see that we are the NT authority system. So we do have the top level privileges on this device. So additionally, what we can do now is start looking at taking this Meterpreter and stealing tokens. So the tokens that we're taking here are for the administrator or any other user on this device. And here we see we have the Windows admin token. We can then utilize this token for further traversing around the network. As we have a Windows admin password, it may be similar to another Windows admin password on a separate device on the network. We can also look at interacting with the terminal a bit more by browsing files. And here we see the Windows directory. So we can now upload, download, or change any of the files that are in place on that compromised terminal. Additionally, we can start looking at dumping password hashes. So the benefits about dumping the password hashes is very similar to the tokens, where we will be able to utilize or reuse these administrator passwords to use as a man-in-the-middle attack, or to use as additional login authentication against other additional systems in the network. Okay, so from this we see that once an intruder has been able to gain access to the network, it's very easy to then look at targeting a device, a vulnerable host, exploiting that host, taking control of that device and escalating the privileges to system user, and then start looking at extracting relevant and potentially unsafe information from those devices. Okay, so that ends the live attack. What I will do now is hand you back to Stacey, who will go through the rest of the presentation with you.
For that, David. So just following on from that, really handy overview there, David. Thank you very much. As you can see on the screen, these are the other services that Lineal Cyber are able to assist you with: security audits, vulnerability assessment scans. That comes included within a penetration test. The difference about vulnerability assessment scan is it's just looking at your open ports and you're pointing it to a range of IPs just to identify those. We can also assist you with cyber incident response, digital forensics, and we also partner with KnowBe4, who are the world's leading end-user training awareness platform. So we'll just have a look to see if we've got any questions to finish this off. Just give a moment in case any comes through. Right, okay. What we will do is we'll plan to answer the questions should they arise. Our consultants will be in touch with you, just see how you found it and if you have any questions that you need answering following this. But if not, thank you very much for joining the Know Your Vulnerabilities webinar for Lineal Cyber, and we look forward to hearing from you soon.